Hi, I'm Mary. Welcome to my channel. We're working on some concepts with functions and graphs of functions, and we work with a worksheet that's posted in the discussion box below. So we're thinking here about piecewise functions, and if you're working with the worksheet, this is number 9. There's some video, part of the lecture came before, and part will come after this one. So we're given a function, a piecewise function, because there are 2 pieces to it. And you can have more than 2, but this one has 2 pieces defined by sort of taking your domain, all of the values that x, all the values of x for your function, and you're breaking it up into 2 chunks. So you define the function here. The function is defined here for all values of x less than 0. And in the second line, for if x is greater than or equal to 0, this is what this function looks like. Okay, and what we want to do first is evaluate it. So I chose some values here for x, and to figure out what f of minus 2 is requires first that we determine if minus 2 belongs in the top row for x less than 0, or if minus 2 belongs in the bottom row is x greater than or equal to 0. So if x equals minus 2, right, then we see x is less than 0. So we know that we need to look at minus 2x minus 1. So we're going to use that, the first row, and substituting in x equals at x equals minus 2. So substituting minus 2 for minus 1, 3. Okay, so f at minus 2 is 3. And I use this little, some of my teachers, friends have told me that it's called a T-chart, that may be a term you would have heard that described by, but I always really, whenever I get a value of x, calculate a function at a given value, just try to record it, because later on, that's really, that's evidence of what this function is going to look like or act like, or whatever it is we need to determine characteristics of a function. So kind of always just keeping a T-chart when you grab a value. So let's go ahead, and we're asked now to evaluate f of x when x equals minus 1. And so x equals minus 1 is also less than 0, right? So then we're going to use the first row. So negative 2x minus 1 when x is equal to minus 1. And we evaluate. I get 1. Record it there. So when x equals 0, which first row or second row? Well, the second row takes over when for x greater than or equal to 0. So the equal to 0 part brings us to the second row. And let's evaluate it then. What we need to evaluate is 4x plus 2 at x equals 0. Just gives us 2. And now as we move to the next 2 values of x, 1 and 2, they're always going to be in the second row. So evaluating 4x plus 2 when x equals 1. We get 4 plus 2, which is 6. And at x equals 2, we get 8 plus 2, 10. Okay, so this is how we evaluate it. Each time we had to determine which part of the function, the first row or the second row, we should be using. Okay, so we're going to graph the function. And the first thing we have to do to graph a function is to draw an axis. So it's XY axis. And we'll put the function over here. And you want to consider the range, the domain of the function when you determine how you want to put your ticks, how you want to define the horizontal axis, right? You want to look at your domain. And then, so here we see that X goes, at least in this part that I have called your attention to, -2 to 2. So let's go ahead and maybe we'll take this out like that. 2 and 0, 1 and 2. Certainly you can extend it a little more, but this is the point of interest for us today. And then the values of that the function takes on, the values of y, what is the range of the function? I see that at least in this region, we're going, I want to at least be able to catch y's between 1 and 10. And this function is defined for all values of x. So I want to just correct my previous statement. The range, the domain of this function, not that I was asked, but yeah, let's go ahead and put it up. Domain of the function are all real numbers. So any value of x, this is defined for, and the range of the function. Well, let's go ahead and graph it and see if we can figure it out then. Okay. So anyway, I want to choose an axis that matches up with the point of the conversation we're currently having here, which is the values I asked you to plot. And I see that we can go we want to make sure we go up to 10. Okay, so when x is -2, the function is 3. When x is -1, the function is 1. When x is 0, the function is 2. When x is 1, the function is 6. And when x is 2, the function is 10. So just graphing the points. And we do see what's going on here is that we have two straight lines. We can tell from the form of the equation. And the line on the left looks like this. Does not rule at when x equals 0. It's the other line that kicks in and it takes control at x equals 0. And it looks like this. Okay, you guys. This is the graph of the piecewise function. Okay, might as well go on over there and answer the range question now, right? So all values that this takes on, it does not take on 0. 0 less than, so no values less than 0 and not 0. So I'm not using a less than or equal to sign. Wow, look at me. Let's get these interval notation. I kind of had to correct the domain notation. Sorry about that. So then this is 0 and it goes up to infinity, doesn't stop. So there's my range. Okay. That's what I wanted to show you about evaluating and graphing piecewise functions. All right, so in my next video, we're going to look at odd functions, even functions. Okay, so I'll see you then. Bye.